Welcome back to the deep dive. Today we're strapping in for a high-speed, thorough tour of the artificial intelligence landscape as we close out 2025.
That's right.
And this isn't just about the latest buzzwords. I mean, this is about the profound, practical, and, sometimes really problematic realities of AI's deployment across sectors that directly affect your life.
Well, and the sources we've been given are, they're concise, but incredibly insightful. It's a comprehensive snapshot of what's happening right now.
Yeah.
The material gives us a detailed look at the daily developments across truly critical sectors, from the intimate world of medicine to the vast decentralized realm of media.
And crucially, the ethics that are supposed to underpin it all.
And crucially, the foundations of trust and ethics.
Exactly.
Okay.
Our mission, as always, for you, the learners, pretty simple. To extract the most important insights and those surprising nuggets of knowledge. We want to make sure you get a fast, thorough overview of what's truly making waves. We want you walking away from this deep dive feeling entirely well-informed, equipped not just with facts, but with context.
Without having to wade through a mountain of technical white papers or, poorly sourced blogs.
Absolutely not. We do the waiting for you.
And the scope of the material, it really spans everything from cutting-edge innovation to the critical ethical pushback it generates, and then, of course, the cultural transformation that comes out of that.
It's a vast ocean of information. It really is.
It is, but we're navigating by three clear pillars today to ensure a logical and a detailed flow for you.
That's right. We are focusing on three major areas. First, we'll spend a significant amount of time looking at AI's growing and, potentially life-saving role in healthcare.
Right, diagnosis and personalized treatment.
Yep, exactly. Examining its impact there. Second, we dive into the critical, ongoing debate surrounding ethics, privacy, and accountability.
And this is where it gets really interesting.
It does. We're specifically tackling sophisticated surveillance concerns and, that urgent global push for transparency.
And finally, we'll turn our attention to AI's sweeping influence on entertainment.
Yeah, the more visible side of things.
This is where the technology is often most visible to the public, yeah. We'll be looking at how it's changing both the personalization of content consumption and the very act of content creation itself.
And in doing so, challenging these, long-held ideas about authorship and creativity.
It's a huge topic.
Okay, let's unpack this. Starting with the transformative and, frankly, pretty astounding changes happening in healthcare thanks to machine learning.
Yeah.
When we talk about AI in medicine, it's not some lab concept anymore, is it? It's actively scaling, saving time, and potentially saving lives right now.
No, not at all. It's the point of friction where massive data efficiency meets, biological complexity. Our sources highlight a core development, the tangible enhancement of diagnostic accuracy, particularly in radiology, which is a field that's often bottlenecked not by talent, but by sheer volume and the constant risk of human fatigue.
And the research we've seen is highly specific on this, focusing on an AI model developed to radically improve diagnostic accuracy in a really critical area.
Right.
The core application is detecting these subtle anomalies in chest x-rays.
Which is high-volume critical analysis.
Oh, unbelievably so. Think about any major hospital. The number of chest x-rays that need a fast, reliable read every single day is just staggering.
Absolutely. And to truly appreciate the magnitude of this, you have to understand the sheer difficulty of the task. A radiologist is looking for minuscule deviations in grayscale, a faint nodule, a subtle interstitial pattern, and they're often doing this hundreds of times in a row under pressure with incredibly high stakes.
And the AI model we're talking about is designed specifically to expedite diagnosis for serious, time-sensitive conditions like pneumonia and lung cancer.
Precisely. That's where speed and accuracy are everything.
So let's talk about the mechanics here for a moment. How does the AI actually achieve this better, faster detection? I mean, we're not talking about simple photo recognition like on your phone.
No, not at all. We're talking about specialized deep learning structures, specifically what are called convolutional neural networks, or CNNs.
Right, CNNs. We hear that term a lot.
And for good reason. These networks are uniquely excellent at spatial pattern recognition. They're trained on millions of labeled images, literally millions of confirmed cases of healthy lungs versus, say, early-stage lung cancer or bacterial pneumonia.
So when a new X-ray comes in, the CNN isn't just checking a database of photos, it's identifying these incredibly complex spatial features across the entire image and comparing them statistically to its massive training corpus. Is that right?
That is exactly right. The human eye might struggle with a low contrast opacity in the corner of a lung field after 5 hours of constant reading. The AI, which has no fatigue, processes the entire image instantly.
And it highlights areas of interest.
Yes, it highlights those areas with a specific statistical probability score. Our sources point out that these models have significantly reduced the false negative rate.
Which is the key metric here.
It's everything. It means fewer times a human misses a sign of cancer that was actually there.
And that reduction in false negatives, I mean, that is the true value proposition. If you can shave off hours or even days in getting a high confidence read on a chest x-ray, especially in a system that's stretched thin, that dramatically changes a patient's entire treatment pathway.
It's a huge deal.
But is this technology designed to replace the human radiologist? That's the fear you always hear.
That is the common fear, you're right. But the data really suggests the opposite. This technology provides a dual impact that focuses on augmentation, not replacement.
Augmentation, all right.
The primary benefit is the alleviation of that significant workload for human radiologists. AI functions as a tireless, highly reliable first-pass filter or, a guaranteed double-check system.
So it's taking the repetitive burden of that initial screening off their plate, which allows them to redirect their finite, valuable time toward the truly ambiguous or complex cases that require nuanced human judgment and, consultation with other doctors.
Precisely. And that makes the overall quality of care the entire department delivers far higher.
Yeah, that makes sense.
The sources state that this provides quicker, more reliable results for patients, which is especially crucial in stressed global healthcare systems.
Right.
And that reliability element is key when we consider the human factor.
Right.
A physician working a double shift is susceptible to fatigue, which can lead to missed details.
Of course.
If the AI is trained on millions of images, its pattern recognition capabilities far exceed what any single human can maintain over a long, grueling shift.
I think we need to connect this to the broader issue of healthcare equity. It's a big part of the conversation. If specialized radiologists are clustered in high-income urban centers, how does AI help a rural hospital with limited resources?
That's a crucial insight, and it's one of those exciting aspects of this. This AI, often delivered via the cloud, essentially democratizes expertise.
Okay, democratizes expertise. I like that.
It means that a remote clinic could potentially access a diagnostic quality check that was previously limited to, big specialized urban centers.
So a doctor in a small town gets a sort of world-class second opinion instantly.
In a way, yes. For instance, the AI can perform preliminary screening for tuberculosis or common pneumonias in underserved regions, accelerating treatment and isolating patients faster. The AI effectively acts as an expert consultant available 24/7, bridging those geographic gaps in medical competency.
That is a generational shift. It really is. But the revolution in healthcare doesn't stop at image processing. That's just the first step.
Right, that's diagnosis.
Exactly. Once a condition is diagnosed, AI is increasingly being used to manage the treatment itself. We're moving beyond simple diagnosis and into the, intensely complex realm of personalized medicine.
This is where the complexity of machine learning truly shines, and where the volume of data becomes just overwhelming for any kind of non-algorithmic analysis.
It's too much for one human brain.
Way too much. Our sources clearly state that machine learning algorithms analyze these vast data sets of patient information, integrating everything from genomics and proteomics to electronic health records, lifestyle factors, historical treatment outcomes, everything.
The sheer scale of that data integration is almost unimaginable. For a human doctor, integrating a patient's family history, their specific gene expression profile, and all the global literature on similar cases is, well, it's nearly impossible to do in real time.
Correct. The core function the algorithms perform here is the prediction factor, forecasting individual patient responses to various treatments.
Right.
Historically, drug dosages and treatment protocols were established through massive clinical trials, which identify what works best for the average patient within that trial population.
Biology isn't average. One person might metabolize a chemotherapy drug completely differently than another based on genetic markers.
And that leads to different side effects or drastically different efficacy rates.
This leads us to the analogy you brought up before, which I think is a really good one. Let's really drill down on this shift. The traditional approach, the one-size-fits-all model, is, as you said, like buying an off-the-rack suit.
It is. It's mass-produced, it fits most people reasonably well, but it's always a compromise on comfort and effectiveness.
And now, AI-driven personalized medicine is the digital tailor.
Exactly.
It doesn't just look at your height and weight. It analyzes the fabric of your genome, your metabolism, your specific tumor markers, your history, and then it predicts with statistical accuracy which treatment plan, which dose, and which combination of therapies will yield the best possible outcomes for your unique biological reality.
Our sources confirm that the outcome is tailoring healthcare plans to meet specific individual needs. This is about precision medicine.
Right.
Moving medicine away from that compromise toward customized plans designed to yield the best possible outcomes for each and every patient, minimizing toxic side effects and maximizing therapeutic response.
But I want to introduce a point of critical friction here. When we talk about this level of personalization, we are dealing with proprietary black box algorithms.
Yes, that's a huge issue.
If a human doctor makes a recommendation, they can explain their reasoning based on published literature and their experience. If an AI tailor says this dose, how do we ensure that recommendation is sound and not based on biased or incomplete data?
100%.
The data set has to be impeccable and the algorithm has to be transparent, or that precision could be devastatingly wrong.
That is a profound concern, and it links directly to our next section. But in healthcare, the stakes demand a much higher level of validation. Currently, these systems aren't autonomous decision-makers.
Your advisory.
They're advisory. They provide probabilistic recommendations to the physician, who remains legally and ethically accountable. The system provides the why based on the data correlation, but the human must validate the clinical relevance. Furthermore, the development of explainable AI, or XAI, is absolutely critical in this sector. We need to demand that algorithms can articulate, even if it's simplified, the key factors that drove the prediction.
So if the AI predicts patient A will have zero response to drug X, the doctor needs to know if that prediction is based on a specific genetic marker or, I don't know, a lifestyle factor. Without that explainability, trust and adoption will be incredibly slow.
Exactly. But the overall implication of getting this right is just huge. This is not just about better treatment, it's about massive resource reduction.
How so?
If AI can predict failure, doctors don't waste crucial time, money, and emotional energy on an ineffective treatment path. They can jump straight to a plan that's predicted to work.
So you skip the trial and error phase.
You skip a lot of it. And when you connect the dots, that diagnosis speed plus personalized treatment plans AI is clearly the key to unlocking more efficient and effective medical care globally. It fundamentally changes the economic model of healthcare.
The scale of impact we just discussed in healthcare is, truly generational. It's affecting life and death.
Absolutely.
And as AI becomes embedded in systems that manage such high stakes, we have to look at the ethical frameworks that are, well, frankly, struggling to keep pace.
Yeah.
Here's where it gets really interesting. Switching gears to the ethical considerations that are shaping the future of AI deployment.
And this transition is so necessary because the more powerful and pervasive the technology gets, the more critical the oversight and transparency have to be.
For sure.
Our sources indicate that recent debates have focused intensely on AI's rapid, sometimes unchecked, role in surveillance and the resulting profound privacy concerns.
The conflict is stark. We're discussing systems that go so far beyond simple security cameras. AI-powered surveillance systems are becoming incredibly sophisticated.
Oh, yeah.
Think about not just automated facial recognition, but technologies capable of gait analysis, identifying a person by the unique way they walk.
Or analyzing microexpressions to gauge emotional state.
Exactly. And all of this is running on enormous data sets, operating silently in the background of our lives.
And this rapid increase in capability leads directly to these growing fears about the implications for civil liberties. The central dilemma for governments and policymakers is that trade-off.
Right.
Proponents argue for enhanced security, efficiency, and safety, the ability to identify threats instantly.
But let's look at the risks of misuse, which are detailed clearly by privacy advocates and, increasingly by certain major tech companies who are seeing the public trust erode.
They see the writing on the wall.
They do. The first and most obvious is the potential for unwarranted invasions of privacy. If every public action, every interaction, every movement is recorded, analyzed, categorized, and scored by an AI, where does private life begin and end?
The distinction dissolves.
It does. You are essentially generating a permanent, comprehensive digital shadow of everyone, everywhere.
And the second risk is perhaps more systemic and pernicious in its potential harm. the risk of algorithmic discrimination.
Let's talk about that.
This is not a hypothetical concern. It is happening right now in predictive policing and judicial applications.
Right now.
If the data used to train surveillance AIs reflects historical biases, for instance, data showing higher rates of arrests or monitoring in specific demographic communities, the AI doesn't just replicate those biases.
It amplifies them. It gives systemic bias this aura of objective statistical legitimacy.
Exactly.
A human system might have inherent biases, but those decisions are visible, they're contestable, and they're based on individual judgment. An algorithm's decision is often opaque, delivered at massive scale, and almost impossible to appeal or even fully understand.
And we should probably define what we mean by algorithmic discrimination in this context. It often stems from what's called proxy bias.
Proxy bias. Okay.
The AI isn't intentionally biased against a protected class, but it finds variables or proxies that correlate highly with that class.
So it's not looking for race, but it might be looking for zip code, which can be a stand-in for race.
That's a perfect example. If a predictive policing model is trained on historical arrest data, and certain neighborhoods were historically over-policed, the model concludes that the neighborhood itself, a proxy for demographics, is the predictive variable for future crime.
Which then leads to further over-policing of that same neighborhood. It's a feedback loop.
It's a vicious feedback loop, and that is precisely why we are seeing a significant and unified regulatory push.
Right.
Our sources highlight that privacy advocates and certain forward-looking tech companies are calling for stricter, clearer regulations to govern the use of AI in surveillance.
It's an unusual alignment, activists and corporations.
It is, but the gravity of the ethical tightrope demands it. They recognize that without trust and clear legal boundaries, the technology itself becomes politically and socially toxic.
So their shared goal is balancing genuine security benefits against the potential for these really deep societal harms.
Yes. The regulations are needed to define strict boundaries like rules around the deployment of facial recognition in public spaces, mandates on data retention limits, and established rights for individuals to challenge algorithmic outcomes.
This regulatory momentum is already visible on the global stage. If we look at the philosophical underpinnings of major global regulatory efforts, there's a move to categorize AI based on risk.
Right. The risk-based approach.
Exactly. High-risk systems, like those used in surveillance or medical diagnosis, they face mandatory pre-deployment auditing and rigorous data transparency requirements.
That brings us to the proactive response, the positive counter-movement toward transparency and accountability in AI development. This is absolutely crucial for building public confidence. We can't rely solely on retroactive law enforcement.
You have to build it right in the first place.
You have to. And what's fascinating here is that the response is multi-layered. It's addressing both the code itself and the organizational culture of AI development.
So it's not just a tech problem.
It's a people problem. Companies are taking specific proactive steps to ensure systems are ethically designed and implemented from the ground up, not just as an afterthought.
Okay, let's break down those proactive steps in detail. What does that actually look like?
Well, first, conducting regular ethical audits. This goes far beyond a simple security or bug check. It involves deliberately testing the system for fairness, robustness, and potential harm against diverse, often simulated, populations before it ever touches a real-world application.
So it's essentially a mandatory stress test for fairness.
You could call it that.
And this process must also specifically test for biases that might be latent in the training data itself. For example, testing whether a system is equally accurate at identifying faces across different skin tones or lighting conditions.
Which was a known, massive failure point in early facial recognition systems.
A huge one.
And this ties directly into the second, non-technical but equally vital point. Engaging with diverse teams specifically to mitigate inherent biases in data and design.
Right, the people part you mentioned.
Bias enters the system at the data collection phase, in the labeling of that data, and in the fundamental outcomes the developers choose to prioritize. If the team building the system reflects only a narrow demographic, they simply cannot spot the blind spots that will affect other demographic groups.
It's just not possible. A diverse team bringing different life experiences and ethical perspectives is really the only practical, real-world mechanism to spot those biases before they become infrastructure.
Finally, there is the push for fostering open dialogues with stakeholders, the public, regulators, experts. This is accountability in action.
So it's not just happening behind closed doors.
It can't be. It means explaining in accessible terms how an AI works, what data it uses, and critically, what its limitations are. It prevents the AI from becoming this hidden, infallible authority that operates outside of democratic scrutiny.
This moves us into the realm of synthetic data as a tool for mitigation. I've been seeing more about this.
Yeah, that's an interesting approach.
Since real-world data often reflects and perpetuates societal bias, some developers are working to generate synthetic data sets that are mathematically balanced and perfectly representative.
So they can train the model on an idealized, unbiased world and then test how it performs against the messy reality.
Exactly.
That strategy is emerging, but it presents its own challenges. If the synthetic data is too divorced from reality, the model may perform well in the lab, but then fail dramatically when encountering real-world noise, complexity, and corruption.
So it's not a silver bullet.
Not at all. The key is triangulation using real data, audited by diverse teams, and tested against rigorous ethical frameworks.
By prioritizing these ethical considerations, these audits, diversity measures, and dialogues, the ultimate goal is clear.
It is.
Ensuring AI development proceeds in a manner that truly benefits society as a whole while minimizing potential negative consequences and harms. It's about building a future that is fair, scalable, and trustworthy.
And the stakes are incredibly high. If we get the ethics of surveillance and bias wrong, we risk not just privacy violations, but undermining the social contract and reinforcing systemic inequalities with the most powerful tools ever invented. That is why this whole section must be about rigorous, proactive framework development.
That tension between power and ethics will, I think, define the next decade.
I agree.
But for now, let's pivot to a sector where the stakes are perhaps less existential than healthcare, but the cultural impact is equally profound, the creative sector.
Right.
Let's look at Section 3, AI in entertainment. AI isn't just a tool here. It's an integrated co-pilot, reshaping how we experience media, often without us even realizing it.
The shift is happening across the entire content pipeline, from consumption personalization to actual creation. Our sources highlight the foundational change in how streaming services operate.
They're entirely data-driven operations now.
Completely and primarily fueled by machine learning. The mechanism is hyper-personalization. AI is used to tailor content recommendations.
Right. This is a sophisticated engine behind why platforms like Netflix or Spotify seem to know exactly what you want to watch or listen to next, sometimes, predicting your interests before you've even consciously registered it.
And to get technical for just a moment, they primarily use two types of filtering. There's collaborative filtering, which analyzes the patterns of millions of users. If people who liked X and Y also like Z, it recommends Z to you.
Okay.
Then there's content-based filtering, which analyzes the features of the content itself. So if you watch period dramas set in England, it recommends other period dramas set in England. AI combines these to create a uniquely compelling feedback loop.
The benefit to the user is obvious. It dramatically reduces what's called choice paralysis. It keeps audiences engaged by matching content exactly to individual viewer preferences. You spend less time scrolling and more time watching.
Which is the platform's primary goal.
Of course. But let's introduce some friction here. While we love the tailored feed, this personalization creates what critics call the filter bubble. If the AI only ever shows you what it thinks you will like, it never exposes you to novel, challenging, or diverse content that might broaden your tastes or challenge your worldview. Doesn't this lead to a kind of cultural stagnation?
That's a valid critique, and it's a necessary trade-off from the platform's perspective. They are aware of this, and they do try to introduce serendipity modules, purposefully injecting slightly off-preference content to test boundaries.
But that's not the main driver.
No. Fundamentally, the business model prioritizes engagement and retention above cultural education. If you stop watching, they lose revenue.
And that leads to the critical benefit for the platform, which is arguably more valuable than just user happiness. Right, an oddly specific example, but a good one.
They don't wait for executives in a boardroom to spot the trend. The AI flags it, allowing them to invest heavily in that niche instantly. This predictive commissioning minimizes risk in content production, which is famously expensive and volatile.
So this feedback loop is just relentless. Every click, every pause, every skip, every rewatch, it all feeds back into the model, refining the understanding of taste and trend.
And it makes the platform experience stickier and reduces subscriber churn, which is the ultimate business metric for a subscription service.
Okay, so moving from consumption to creation, the use of AI-driven tools is enabling some really serious innovation in the creative process itself.
It is.
Our sources mention specific boundary-pushing applications in both music and film production that are truly redefining the speed and quality of output.
This utilization allows for highly innovative approaches to creating and editing content. Think about massive film production projects. AI can analyze millions of frames and instantly suggest optimal cuts based on cinematic principles, pacing, and even audience engagement prediction models.
Wow.
It can automate incredibly tedious processes like rotoscoping, color grading, or stabilization of handheld shots at a fraction of the time and cost.
That's pure efficiency. And in music, this is pushing technological boundaries in production quality.
It is. AI can compose background scores based purely on a film's emotional arcs, analyzing the script or scene timing and generating a score that matches mood and pacing perfectly.
That's incredible.
Or, in post-production, it can clean up dialogue tracks faster and more effectively than any traditional engineer, isolating voices from background noise with stunning accuracy.
So it democratizes high-end production.
To a degree, yes. The efficiency gains mean smaller studios or independent creators can produce high-quality work that previously required enormous teams and specialized budgets.
But the most culturally challenging development is generative AI, this whole art and authorship question.
Right. This is where it gets philosophical.
It does. We're talking about algorithms that don't just optimize existing content, but create entirely new pieces. The headline event, according to our sources, is that AI-generated art is making headlines, with some pieces fetching impressive prices at auctions.
And that price point, that injects immediate economic reality into what was previously just a philosophical debate.
Absolutely. What's fascinating here is that if an AI creates a piece, and that piece sells for a significant sum, it forces us to reevaluate how we assign cultural and monetary value.
It raises profound and intriguing questions about the very nature of creativity and authorship when the output is generated by an artificial entity.
So let's delve into the mechanics here for a second. These are typically diffusion models or large-scale generative adversarial networks, right?
Yes, GANs. They're trained on billions of images, basically the entire visual history of human art and photography that exists online.
And the human user provides a simple text prompt like, a moody landscape painting of a robot contemplating a sunset.
A great prompt. And the AI generates a novel image by gradually adding noise and then learning to denoise it back into a coherent image that satisfies that prompt.
But the output is novel, even if it is derived from existing work. And that's the rub.
It is. It challenges our deep-seated human belief that art must stem from human intention, human suffering, or some unique human experience. If the AI is merely executing complex algorithms based on existing data, is it truly creative? Or is it a highly sophisticated mimic?
And if it is only a mimic, who is the author? I mean, this is not just an academic question, it's a legal one.
A huge legal one.
The creative industries are currently grappling with massive copyright infringement lawsuits. Artists are claiming that since their work was used, often without permission or compensation, to train the model's output is, in effect, derivative and violates their copyright.
And the legal and philosophical foundations of copyright are under intense pressure. Is the author the person who wrote the prompt? The prompt engineer? Is it the engineer who built the algorithm?
Or is it the millions of artists whose work was used to train the model?
Exactly. The courts are struggling to define the precise point of creative input that qualifies for protection in this new ecosystem.
And this volatility is driven entirely by the value. If an AI image was just a curiosity, the conversation would be muted. But the fact that some pieces are selling for impressive prices at recognized auctions proves that the market perceives inherent value.
Which forces the legal system to catch up quickly.
Yeah. The broader implication is clear. AI is pushing boundaries and reshaping how society creates and consumes media in exciting and very fast-moving ways.
From hyper-personalized streaming cues that manage your mood to algorithms generating auction-worthy masterpieces, the entire creative world has fundamentally changed.
And the speed of change in entertainment is often a harbinger for society. People may accept the philosophical ambiguity of AI art faster than they will accept the opacity of an AI that determines their medical diagnosis or their risk profile in a surveillance system.
That's a great point.
It sets up a fascinating contrast in accountability that we need to address as we close out. So what does this all mean? We've just covered three massive disparate sectors: healthcare, ethics, and entertainment in one deep dive, all united by the same foundational technology.
Machine learning and vast data analysis.
Exactly. And it means the AI landscape is evolving rapidly, and understanding these three sectors, which encompass survival, regulation, and culture, provides a crucial shortcut to being well-informed.
AI isn't a single product. It is infrastructure that underpins everything we do now.
The interconnectedness is really striking. The same core technological approach is being applied to predict cancer progression with life-saving results, to enable sophisticated surveillance systems that challenge civil liberties, and, to predict your next binge watch or generate high-value fine art.
Both are forms of prediction, but the consequences of error are wildly different.
And that profound difference in consequence leads us directly to the crucial point we want you to mull over. Let's return to that stark contrast between AI in medicine and AI in art.
Right.
We noted that AI can accurately detect life-threatening anomalies, like lung cancer, and also create art valuable enough for auction, proving its perceived worth in two very different arenas.
Okay.
So here's the final provocative thought we want to leave you with, which should drive your critical thinking as a learner. Should the ethical and regulatory framework governing these two very different outputs be the same?
Or do we need vastly different accountability standards for algorithms with high stakes life and death versus those with high cultural and economic value, like creativity and authorship?
Consider the hierarchy of accountability. If a medical AI makes an error in diagnosis, the consequences are immediate, potentially catastrophic, and involve existential harm.
So we demand extreme transparency, rigorous audits, and human oversight.
Of course we do. However, if an artistic AI merely copies a style too closely, the consequence is a cultural or legal debate over copyright, a financial or intellectual property loss.
A very different kind of harm.
A very different kind. Does this necessitate a medical-grade or life-critical AI regulation that far surpasses the governance we apply to creative-grade AI, where the cost of error is primarily economic or aesthetic?
The complexity of AI is forcing us to create entirely new hierarchies of trust and consequence. Where does accountability rest when the system is inherently probabilistic?
It's a huge question.
We have to decide if a near-perfect AI diagnosis tool is better than a fatigued human one, and we must accept the risk hierarchy that comes with that choice.
It's a question that will drive legislative action, corporate responsibility, and consumer acceptance for the next generation. A fantastic deep dive into our sources today.
It was.
Thank you for joining us on this essential exploration of the cutting edge of AI. Until next time, stay curious and keep exploring.